in accordance with restrictive signal aspect approaching ahead. The Indian Railways
Sir, PCSTs are already joined. So I'll just. Good morning, sir.
Good morning, Manjunath. We may start.
Yes, sir. Sir, just to. Good morning, one and all. Respected PCST, sir. CAC, sir. CST project, sir. All other HODs, deputy CSTs, senior DSTs, other officers, supervisors, and technical staff of the SNT, ladies and gentlemen. Today's webinar topic is most relevant to our SNT fraternity. That is Fitment of Loco KAVACH, Challenges Encountered and Solutions. This has been presented by none other than Sri M. Munikumar, Deputy CST, Delhi Projects. He is instrumental in successful deployment of 1,190 route kilometers of KAVACH section with the completion of onboard KAVACH fitment in more than 130 locomotives of different classes. He is an IRSSC 2006 batch officer, joined in Indian Railways in 2008 after completion of his MTech in IIT Mumbai. Prior to this, he was worked as a senior district Guntur. Now I request PCST sir to brief a little bit about this topic, and later Sri Munikumar sir will take over this webinar section. I request PCST sir to say a few words, sir.
Yeah, good morning, one and all. And thank you, Manjunath, for introducing the speaker and subject. I think more than 50, 60 people have already joined, and many more will be joining. The only thing I want to say is that this is one of the most challenging work in front of the SNT fraternity over the Indian Railways. It is not only limited to South Central, but almost all major railways covering the entire uh, New Delhi to Howrah and New Delhi Bombay route. Zones like Eastern Railway, ECR, NCR, WCR, Western Railway, NWR. So all these railways are involved in this work, and I hope that the insight gained by the Tele project team of South Central Railway will be a torch bearer to educate the people who are going to implement this new technology successfully for not only the benefit of the Indian Railways, but for the benefit of the South Central Railway, SNT fraternity also, because it is a challenge to SNT community of Indian Railways, and we have to ensure that we succeed in that instead of making the technology blameworthy. So I hope that the insight gained by the Mani Kumar and his team will be shared fruitfully among these attendees, and attendees will not hesitate to ask questions, even the uncomfortable questions, and even rather ridiculous questions also, so that at least it can be clarified by the Mani Kumar and his team. And I hope our CSC project, VNM Rao, is also available, and he will be also a very, you can say, experienced officer in this technology, and plus moreover, he will be clearing doubts, many more doubts, what will be coming in the mind of the people after hearing the presentation. So let Mani Kumar take over. Thank you.
Thank you, PCC sir. Just before that, I'll tell one word, sir. Actually, sir, with your guidance, we have really become a torchbearer, because we used to get a lot of doubts from various railways, particularly in the ROCO, which is not our core subject. Apart from that, we are along with RDSO, we have been doing successful trials for getting this braking parameters for various type of stocks. So this is also Mahmood task, sir. Takes at least 1 month, minimum 1 month, for arranging the crew, path, and staff for various RDSO staff, as well as our own staff and all. for doing these braking parameters. Nevertheless, sir, this is a rich experience given and opportunity got from Railway Board and RESO to Southern Railway. I am sure that the remaining particular mission of the railways will definitely benefit out of our experience. And we are also, as under your guidance, we are also making manuals as well as what you can say files, various compendium and other materials, which is really useful for other railways to implement easily. So we confirm, sir, that we are almost in the final leg of making all the things perfectly to see that other railways will be benefited out of our experience. We will share all the documents, compendium, and other policy letters, guidance letters, all these things to RDSO or to other railways, sir. Thank you, sir. Munikumar, you can take over.
Yes, sir. Yes, sir. Yes, sir. Yes, 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 yes.
I think you have logged in from the two different devices from the same room.
Yes, sir. Yes, sir.
It is creating
Now I
issue.
rectified,
Please,
sir.
please log out.
Yes, sir. Yes, sir. Sir, I rectified that issue, the technical issue. Very good morning, sir. Respected PCST, sir, and senior HODs, senior officers, colleague officers, and SSCs and other staff from the various units. Very good morning. So, under the guidance of PCST, it is really challenging for us to implement the Loco KAVACH implementation. This is a vast subject and different from our regular S&D. So that's why today's section, I am mainly focusing on the introductory part and easy understanding of the Loco KAVACH fitment. So before that, I want to showcase some small informative video on the KAVACH system.
Train Collision Avoidance System, also known as KAVACH, is an indigenously developed automatic train protection system under the aegis of RDSO. KAVACH is designed to provide protection to trains against signal passing at danger, excessive speed, and train collisions caused due to human error. KAVACH serves as a major testament to ambitious plans of Indian Railways to ensure safety in train operations over high-speed and high-density network. KAVACH is designed to assist loco pilots with display of crucial information pertaining to approaching signal aspects in the loco through driver-machine interface, DMI. KAVACH will alert the loco pilots to reduce speed proportionately in accordance with restrictive signal aspect approaching ahead. In case the loco pilot still fails to respond appropriately, KAVACH takes over and automatically applies brake in a phased manner until the speed of the train is restricted in order to ensure zero chances of signal passing at danger. This is especially helpful during extreme weather conditions where the loco pilots are unable to sight the signal aspects. KAVACH is a comprehensive automatic train protection system, works on the principle of continuous update of movement authority, which is featured in advanced train protection systems used across the world. The station KAVACH unit computes the movement authority based on approaching signal aspects and location of the train. KAVACH works by constantly sharing information within the three major subsystems such as Station KAVACH, Loco KAVACH, and on-track equipment RFID tags. RFID tags are installed on the track at every 1 kilometer in the block section, at approach of signals and at every berthing track. The static information such as location information, track identity of the RFID tags mounted on the rail sleepers are captured via RFID readers attached to the loco. The same is transmitted to Station KAVACH via radio communication from Loco KAVACH. The station Kavach gains information regarding the location and direction of the train entering in its jurisdiction from local Kavach. The station Kavach unit is interfaced with the station signal interlocking system and continuously acquires the vital signal information. The station Kavach will update the loco pilot about the approaching signal ahead and permitted speeds through driver-machine interface (DMI) of loco Kavach. DMI displays target speed, movement authority, signal aspect, location of the train, and also allows the loco pilot to send SOS messages during emergencies. In order to transmit data in a fast and secured way, the information from station Kavach is transmitted to several local Kavach through station radio antenna mounted on the tower. Every station, mid-section interlock level crossing gate and IB hut are provided with a tower of 40 meters height. This enables transmission and reception of radio signals within the range of 4.5 kilometers, thereby ensuring maximum coverage. Kavach ensures that only authenticated systems will be able to access information shared. This is made possible with radio encryption by using Key Management System (KMS). The system information is exchanged via secret keys, duly ensuring maximum security. Network monitoring system helps in troubleshooting errors through real-time monitoring via a central server located at the divisional office, which is connected to all the stations with OFC network. All the events of station Kavach and loco Kavach are being monitored continuously via NMS for predictive and preventive maintenance. Kavach is an indigenously developed state-of-the-art technology to ensure higher standards of safety in train operations. In case loco pilot fails to control the speed of the train while approaching the danger aspect of the signal, Kavach will take over automatically and apply brakes to stop before the red signal. In the absence of Kavach, the SPAD may lead to collision. Kavach is designed to avoid collisions in the block section due to human errors during manual train operations in case of failure of signal interlocking systems. In an unusual scenario where two trains are approaching each other in opposite direction on the same line, loco Kavach of both the trains automatically apply brakes to bring the trains to a stop. In the absence of Kavach, this scenario may result in head-on or rear-end collision. While negotiating the crossovers at station to enter loop line, loco pilot shall adhere to restricted speed of 15 km per hour or 30 km per hour. Kavach informs the target speed to be followed by the loco pilot before approaching loop lines. In case of excessive speed above the target speed, Kavach automatically brings down the speed to the required speed by duly actuating the brake system, thereby avoiding chances of derailment. Loco pilot has to adhere to the permanent speed restrictions imposed in the section. These permanent speed restrictions exist at locations like bridges, sharp curves, etc. In case of the failure of loco pilot to control the speed of the train while approaching permanent speed restriction zones, Kavach takes over and reduces the speed to desirable limits to avoid any unusual incidents. The station master can alert the locos by broadcasting SOS messages during emergency situations like flooding of tracks, landslides, etc. within its communication range. Similarly, loco pilot can send SOS messages to station Kavach and other loco Kavach in case of emergencies or unusual occurrences. The loco horn is automatically triggered while approaching the level crossing gate to alert the road vehicle users. RDSO has developed KAVACH by collaborating with 3 Indian firms, duly ensuring the interoperability among them. The loco KAVACH of one make is interoperable with station KAVACH and trackside equipment of another make and vice versa for seamless train operations. Indian Railways takes pride in developing the indigenously developed technology in collaboration with Indian firms to fulfill the Make in India mission of Honorable Prime Minister Shri Narendra Modi ji. Indian Railways' ambitious plan to implement train collision avoidance system, KAVACH, over its network is a stepping stone in building Atmanirbhar Bharat.
Once again, good morning, all of you. At this point, I want to inform the forum that this beautiful video is brainchild of our PCST sir. During his busy schedule, he has taken some time and critically reviewed this video and given very valuable inputs to the video. And sir has given the perfect shape to the video. I hope everybody has understood the basic concept of the KAVACH system. Anybody has any doubts, you can always ask or you can put in the chat box. Now I will go to my regular presentation. Just in the video, we have seen the functionality of the tickets. That means in the station, we are putting station tickets and the station tickets is connected to the 40 minutes tower in the station. Station tickets will collect the information available in the relay room, that is required point information, track circuit information, signal aspects. And all this information is fed to the radio modems at the tower location. And our track is equipped with the RFID tags, that is every 1 kilometer in the block section. And so, as we have seen in the video, our station tickets is installed in the stations and it is connected to the tower. Station tickets will collect the required signal information available in the relay room and same information fed to the radio modems. And similarly, our track is equipped with the RFID tags at every 1 kilometer in the block section, at berthing tracks, signals and points in the station section. Let us say our loco equipped with loco KAVACH is running on the track. What will happen? So whenever it encounters the RFID tags, it reads the RFID tags through RFID reader available in the locomotive. So with this, the location information is available with the loco KAVACH installed in the locomotive. Once location information available, loco tickets will start broadcasting its packets with the location details. So whenever station receives any packet from the loco, it will detect whether this loco is pertaining to its own jurisdiction or not, depending on the location data. Once station identifies that loco pertains to its own jurisdiction, then it establishes the secured communication with the loco tickets in the UHF band. So once communication is established between the loco tickets and the station tickets, then there would be transfer information between the loco tickets and station tickets. So in this way, the station dekas will transfer the movement authority and signal aspect to the Loco KAVACH. Based on this data, Loco KAVACH will compare its required speed and current speed. If current speed is more than the required speed, then Loco KAVACH will initiate the braking system to avoid the spads. This is the basic function of the TICAS. Next, we go to our TICAS stator in the Southern Railway. Southern Railway has executed two works. First work is in around Vikarabad section, that is 265 kilometers, starting from the Sanatnath to Vikarabad, one leg, Vikarabad to Wadi, and Wadi to Vikarabad. Next project, South Railway executed from Nagarsoil to Mudkhed, Mudkhed to Guntakal, and Bidar to Parli Parbani. Altogether, our scope is 1465 route kilometers. Out of these 1465 route kilometers, 1455 route kilometers has been successfully completed, and the pending patch in and around the Secunderabad will be completed by this month end. As part of these two works, in the first work, our locos scope is 40 locomotives. We have successfully completed. As part of the second work, that is Nagarsoil to Guntakal and Bidar to Parli Parbani, locomotive scope is 160. Total altogether is 200. Out of this, only 30 locomotives are pending and 170 locomotives are completed. Next, our today's topic is Loco KAVACH fitment and challenges face solutions. Next, we will enter into the Loco subsystems. What are the Loco subsystems considered and how it works? Basically, for each Loco, we have to put two items. First one is Loco KAVACH, second one is brake interface unit. In the Loco KAVACH, we have onboard vital computer, radio units, RFID reader, RF antennas, GSM GPS antennas, pulse generators for detection of speed, driver mesh interface to disseminate the information to the drivers. This all constitutes the Loco KAVACH part. And in addition to Loco KAVACH, we have to put brake interface unit. That is the interface equipment between the existing brake system of the locomotive and our Loco KAVACH. This Loco KAVACH is common for all types of locomotives. So due to some technical problems, my voice could not be heard. I just repeat these slides. So South Railway has executed two works. First one is 265 kilometers in and around Vikarabad section. Second one is 1200 kilometers work, starting from the Nagarsoil of Nanded division up to Mudkhed and Mudkhed to Dhon of Hyderabad division, Dhon to Guntakal, and the other bit is Bidar to Palli Parbhani. This altogether, our scope is 1465. Out of these 1465, only leftover part is around in and around Secunderabad, that is 10 kilometers. By this month end, we will commission the balance portion of the Kavach also. As part of these two works, our Kavach Loco portion is in the first work, our scope is 40 locomotives. In the second, our scope is 160 locomotives. Altogether, there are total 200 locomotives. Out of these 200 locomotives, 170 locomotive fitment has been completed, 30 is in progress. Next, while coming to our actual point today, that is Kavach onboard equipment. Manjunath, my voice is clear?
Sir, clear.
Yes, sir. Clear, sir.
Thank you. Okay, our basic subsystems are loco fitment. Today our topic is Kavach onboard equipment. For putting our Kavach into locomotives, we need two basic subsystems, that is Loco Kavach. Second one is brake interface unit. The Loco Kavach consists of onboard vital computer, radio units, RFID readers, RF antenna, GSM GPS antenna, pulse generators for measuring the speed of the locomotive, driver machine interface, etc. This Loco Kavach is common for all types of locomotives, whereas brake interface unit is different for different types of locomotives. This is the interface unit between our Loco Kavach and existing braking system. Next, we'll see different types of locomotives just as a glimpse. In the first row, you can see the WAG1, WAG4, WM4. These are the absolute powers. In the middle row, you can observe WAG5, WAG7, WAP4. WAG stands for broad gauge electrical goods locomotive. G stands for goods. Similarly, WAP4 in the middle row, this is a AC broad gauge passenger locomotive. The locomotives indicated in the middle row are conventional locomotives, whereas in the bottom row, we have WAP7, that is electrical passenger locomotive, WAG9, that is goods AC locomotive. These two are the three-phase locomotives. That means in electric locomotives, we have three types. One is conventional locomotives, other one is three-phase locomotives. Examples of conventional locomotives are WAP4, that means AC passenger 4, WAG7, that is goods locomotive electrical 7. So for this type of locomotives, the required BAU is IRAB, Indian Railways Air Braking System. This BAU will be manufactured by our Kavach vendors, Meda, HBL, and Lotus also approved vendor from the RTSO. That means if you want to fix our Kavach into conventional locomotives, then we have to use our IRAB type BAU. This would be generated by Meda, HBL, Lotus. While coming to three-phase locomotives, that is WAP5, WAP7 and WAG9. In these three-phase locomotives, we had two different versions of brakes available. That is, one thing is E70, other one is CCB, computer controlled braking system. E70, for E70 type of locomotive, we have to buy our BAU from the Feveli. Similarly, for CCB type, we have to buy BAU from the Norbremse. They are the original equipment manufacturers of the existing brake system of the locomotives. Similarly, we will go to the diesel locomotive. Diesel also same, conventional locomotives and HHP locomotives. In the conventional, the examples are WDG3A, WDM3A, WDM3D. In this, majority, 99% of the locomotives are IRAB type braking system only. So same, here also the vendors are Meda, HBL, Lotus. Very few locomotives.
देख पीता है देखो पानी पूरा
Arif Khan, JE Tele Khammam, kindly mute yourself. So out of these conventional locomotives, very few, 1 or 2% are from the CCB. So that means we have to buy the BAU from the Norbremse. While coming to HHP locomotives, we had two versions are there, CCB 1.5, CCB 2.0. For both BAU same, we had to buy from the Norbremse. So this is the summary of our onboard Kavach equipment, that is RFID readers, pulse generators, Locotica's vital computer, driver machine interface, radio unit, and RF antennas, brake interface units. Next, we will see where we have to install these equipments into locos. So this is the brief block diagram of the locomotive. So generally RFID readers will be installed behind the cattle guard at the under truck arrangement. In general, in loco, we are using everything into two numbers. In the cab 1 side and cab 2 side. Here you can observe RFID reader at the front end, similarly at the back end. So while coming to DMI is driver machine interface. So this is a small display equipment provided in the driving cab. This is the driving cab. You can see small blue color dot, DMI, driver machine interface. If you come to the roof of the loco, here you can see provision for the GSM GPS antennas and RF antennas. Here we are putting in the cab 1 side, we will provide one receiver antenna, one transmitter antenna. Similarly, at the other end also, we are putting one transmitting antenna, one receiving antenna. So here also we have the provision for GSM GPS antenna in separate hood. In the same hood, we have the provision for GSM and GPS antennas. While coming to our main onboard computer, that we call it as a Locoticas, also known as control equipment, and adjacent to that one is BAU. Each Locoticas will be interfaced with two radio units, radio 1 and radio 2. These radio 2 equipments are connected to the antennas, RF antennas. This is the brief layout of the Loco KAVACH. For putting these equipments, we will get the RDS approved layout plans. So this is one of the example. In the top view and we can side view, you can see these equipments. In the top view, there is indication of radio modem antennas and GPS antennas. Similarly, here there is a provision for SMOs, a DMI, driver machine interface, and also place for the TICAs, BAUs. In the cap 2 also we have the provision for driver machine interfaces. At the bottom, under frame arrangements, we have two RFID readers. This is one RFID reader. This is one RFID reader. And at the axles, we have the pulse generators. This is about the electrical locomotive. Now, while coming to the diesel locomotive, here generally we have in the conventional locomotives, we have only one cab. We are putting for long hood and short hood, both the DMIs in the same cab only. This is the provision for the DMIs. And this portion we call it as a nose cabin. Generally in the nose cabin, short hood side, we install our Loco KAVACH and the required BAU. And on the rooftop, we install the RF antennas and GPS antennas. This is the typical layout of the diesel locomotive for KAVACH fitment. Next, we will see what are the considerations for nomination of locomotives. So the basic points we'll consider before going for the allotment of the locomotives for coach fitment. First one is deployment of 25 kV RE works, progress and targeted coach territory. After the RE is commissioned, the running of diesel locomotive will be replaced with electrical locomotives. So depending on the position of the RE in the section, the decision will be taken. Second one is type of stock plying in the section. That is whether it is a diesel section, electrical, EMU, demo, memo. It is always prudent to nominate the concerned locos plying in the cover section for fitment. For example, if you install onboard coverage equipment in the WAP7 locomotives and these locomotives are not running in our targeted cover section, then the benefit of coverage could not be obtained. So that's why, depending on the locos running in the cover section, that particular loco, if you install, then we'll get the maximum benefit out of the coverage. Next one is residual life of the locos. Generally, the loco life is almost 30 to 35 years. It is better to go for onboard fitment in locomotives with more residual life to avoid the frequent redeployments during the loco condemnation. So in this regard, priority may be given for electric locos with more residual life, because board has taken the decision that even the diesel locomotives with the age of 15 years, they are now given instructions that surplus diesel locomotives can be condemned. So that's why it is always preferable to go for the electric locomotives for coverage fitment. Second one is in-circuit movements. That means if the equipped locomotive should be properly monitored, tracked to have more runs, trips in the coverage territory. If we have our equipped locos within our coverage territory, we can get more coverage runs. Tracking of goods locomotive is difficult as it generally goes beyond the zones, and hence less priority may be given for goods locomotives. One experience we got is in the project 1, all electrical locomotives 20 are goods only. So tracking these locomotives and confining these locomotives only into our coverage territory is a really challenging work. That's why in the project 2, 1200 kilometers, we have taken the decision that instead of goods locomotives, coverage fitment may be planned in the passenger locomotives. Similarly, study of loco links also plays major role. We had to study the loco links for having maximum trips in coverage section and transfer of locos to other sheds, duly ensuring the maintainability. That means initially, as per the nomination, we have installed our coverage into Guntakal loco shed. At that time, the section between the Kachiguda to Guntakal is not commissioned. So all these locos are not running in the coverage section. Then, with close coordination with the headquarters, we have transferred these locos available in the Guntakal shed to Maulali shed. Then we are having the maximum runs of these locomotives, as these locos are running in the our coverage territory in the Vikaraba section. So one more thing is putting the locos for daily trains may be preferable over the non-daily trains to have the optimum utilization of the coverage fitted locomotives in the coverage territory. These are the considerations we consider for allotment of the locomotives for coverage fitment. Anybody has any doubts, you can ask me or you can put into a chat box also. So we will go to the next slide, that is sequence of works. What are the works involved in the onboard coverage fitment? First of all, after allotment of these locomotives, survey of all these allotted locomotives are compulsory because the space is not uniform. Next one is provision of required materials for installation and commissioning. After material is procured, we had to start with welding works. Different frames we had to weld for the mounting of our coverage subsystems. Once the systems are mounted, then we have to do the cables routing and terminations. That is, one is under truck arrangement, other one is in the rooftop. After this cabling is done, parallelly we also start the pneumatic connections to existing BAU. So once this installation part is completed, then software configuration part. As per the RTS approved manual, the required parameters will be loaded into the Loco KAVACH and testing will be done. Once all these tests are done, then with the help of the shed people and OEM site engineer, we will do the pre-commissioning checklist. So after this PCL is completed, with the help of the operating department, we are doing the one-day trial run with the station interface testing that we call it as a Loco SAT. After all these test scenarios, we are offering this Loco to the ISA certification at the end of the project. And after ISA is obtained, we will take the sanction of the competent authority from the Southern Railway and we are declaring this system is commissioned. These are the brief sequence of the works available in the Loco KAVACH fitment. Next, we will see some photographs of Loco KAVACH works. So this is the welding work. Initially, as a part of our onboard equipment fitment, we will complete the different frames and stands welding. Over these welded frames, we will mount our onboard equipment subsystems. So first one is our main Loco TICAS and its associated isolation unit. Next, RFID power supply units, driver machine interface, radio unit 1. This is radio unit 2. These are the cable ducts available in the WAP7 locomotive. Next, as part of our Loco KAVACH fitment, we have to install 2 numbers of pulse generators on different axles. This is one example, and this is connected to our pulse generator junction box. Similarly, on the rooftop, we have the provision for RF antenna and GPS GSM antennas. In the bottom of the Loco, we have to install our RFID reader, frame, antenna, power supply structure. This is the arrangement, RFID reader. This one is the cattle guard. We are installing our RFID reader just behind the cattle guard, below the CBC coupler. Next, we will see what are different types of challenges we have faced, being the first time we installed in these items in the Locos. First, we started our installation in the diesel locomotives. In WDG3A type of locomotives available in the Molali, in some locomotives we have the auxiliary power unit that we call it APU in the nose compartment, and this bigger unit occupies our nominated space for the KAVACH. Hence, there is no space to accommodate the Loco TICAS. Only BAE control unit and pneumatic panels can be accommodated. So, as an alternative, in approach with the shed officials, they suggested to install our Loco TICAS into alternate room, back side of the control panel. These are the figures of the KAVACH control unit installed in the alternate room. This is the existing Loco APU available. So the remaining space we have utilized for the installation of the BAU electronics and BAU pneumatic panel. This is the one challenge we face in the WDJ3A type locomotive in the Molali diesel shed. Similarly, in WDM3D locomotives at a Guntakal diesel loco shed, we have one more peculiar problem. There we don't have the APU, but we have an unused AC panel in the nose compartment. As I said, in the diesel locomotives, we are installing our KAVACH equipment in the nose compartment, that is towards the shortwood side. There, the space is occupied by the AC panel. So then we, with close coordination with the shed people, with we have dismantled the unused AC panel and shifted the pressure switches from the nose compartment and completed the fitment of Loco TICAS and BAU pneumatic panels. Before shifting, here we can see the unused AC panel available here and pressure switches. So we have shifted these things and we have installed our KAVACH system. These are KAVACH radios and BAU pneumatic panel, BAU electronics, Loco TICAS. This is the one challenge we faced in the WDM 3D type of diesel locomotive at Guntakal diesel shed. So while coming to electric locomotives, initially we started with the goods locomotive, that is WAG7. In the WAG7 28414 locomotive, there was a baby compressor obstructing our installation. So again, after so much of deliberations and correspondence with headquarters and shed people, after almost a month, we struggled and we are ready to spare the funds for shipping of these equipments. Finally, we are able to shift this baby compressor and we get the space for Loco KAVACH and BAU. Finally, we installed in the WAG7 our Loco KAVACH and BAU. Here, this space is earlier occupied with baby compressor with close quarters shed officials. We shifted this baby compressor and we get the space and we install our Loco KAVACH and BAU. Next, while coming to the conventional, after having the diesel locomotive installation and goods locomotive, at the time we had taken the decision that we will go for the passenger locomotive. That too, conventional or three-phase. We are familiar with the conventional. We opted for the conventional electrical passenger locomotive. These locomotives are available in Vijayawada LS shed. There are two kinds of locomotives available, that is 22 series and 25 series. The total strength, holding strength of the LS Vijayawada is 68 numbers are WAP4. In this, 60 numbers are 22 series and 8 are 25 series. So why we are considering about these 22 series and 25 series? 22 series locos are little old and the space inside the machine room is very limited, not at all feasible to install our Loco KAVACH. So initially we offered this Loco to 3 vendors and 2 vendors said that they could not install their Loco KAVACH into this type of locomotive. Then a third vendor came and he agreed because of his modular approach of equipments. He is able to do it in the 25 series type of WAP4. So what is the difference between 22 series and 25 series? Air compressors are accommodated in underslung arrangement in 25 series WAP4 locomotive, whereas in the 22 series, these air compressors are available in the machine room. That's why in the 22 series, we don't have the space for the onboard KAVACH in 22 series. Out of these 8 25 series locomotives, at one locomotive, that number is 25006, that air compressor has got defective. Then what they did, they have shifted this air compressor to machine room because they don't have the technology at the time to repair the underslung arrangement. That's why they restored back to machine room. That's why this is also posing one more challenge of putting our Loco KAVACH into 25 series 25006 also. While coming to other challenges, in the back side of the cattle guard, near cap 2 side, our RFID reader position is obstructed by the MR tank. So then for this one, our vendors have designed specific design for to suit with this existing space to fit our RFID reader. And otherwise, this is our actual position to fix our RFID reader. So with the presence of MR tank, this side, cap 2 side, our vendors designed sleek arrangement RFID reader. This is one more challenge, exclusive for the WAP4 25 series. So KAVACH fitment in WAP4 is not an easy task for OEMs. Need modular approach for equipment design and shifting of existing utilities in machine room, which involves financial implications, time scales, shed outages also, responsibilities and necessary approvals. So here I am showing the air compressors shifted from machine room to underslung arrangement in the 25 series WAP4 locomotives. So in the recent past, we have taken the challenge of putting our Kavach into EMUs also. Even that this is not into our initial scope of work. Later we modified and we ventured into the fitment of Kavach into EMUs also. EMUs is being the first time for the all the three vendors, and it has taken little time. And I will explain the different problems we have faced and how we have solved those things. Routing of pneumatic pipe connections to the Kavach brake system, that is MR and EM valves, requires coach body lifting from bogie, duly removing the traction motor cables, which generally occurs during the POH at workshop, and possible to carry out the pneumatic piping without joints during the POH schedules. That means if we want to run our pneumatic piping, the coach body should be lifted from the bogie, which requires additional efforts of the shed. They have to engage 8 manpower and lifts also. So they are telling that this is additional and we cannot do on a regular basis. This hampers the regular maintenance effect. So initially for this one, we had to wait for almost 30 days or 45 days for completion of the each EMU. Next, without, we have explored the possibility of without lifting. Is there any approved means are available? Then without body lifting at a car shed, which necessitates intersecting joint for MR pipes. So in the first one, piping, pneumatic piping without joint with the help of body lifting. Second one is piping with joints without body lifting. So second we have got this intersecting of joints, which is approved means in the EMUs. Then we have expanded our Kavach fitment in the EMUs. So fitment of onboard Kavach needs close monitoring of the PO schedules and coordination with the shed workshop officials for time start allotment. This is one challenge regarding the drawing of the pipes, pneumatic pipes. Next one is Kavach fitment and PG covers. Existing motor bearing axle cover doesn't have feasibility for PG fitment. In the locomotive, we can modify the existing PG covers and we can make hole and other provisions and we can install our PGs. Whereas in the EMU PG covers, the modification is not possible. It is not possible to modify the existing axle cover due to less depth, and shed official warned that it may cause oozing of grease during the run. Whereas this modification is allowed and possible in the locomotives. This is a new challenge we faced. And for this one, we had to procure the customized end covers as per the ICF drawing number SK02178. So this also little time taken, and we have waited for approved vendors. We have got the material from the Chennai ICF and we have executed this work. In the below diagrams, you can see the normal cover, PG cover without the provision for the PG. Here, this is the axle cover without the provision of the PG fitment. So we had to replace this cover with customized axle cover like this. And we have the provision here. We have the provision for fitment of the PGs. Here we have fixed the PGs. For this one, our installation in the EM is almost stalled for more than 1 month. Similarly, now in the EMUs there are two types. One is conventional EMUs, other one is three-phase EMUs. Three-phase EMUs also we face a space constraint. There is no space available for fitment of our Kavach inside our three-phase. So, what is the possibility? In the last coach adjacent to driver cabin, there is a seat, three-seat. Removal of this passenger seat, which is available at back side of the driver cab, is the only solution, and same is suggested by ICF also. And as per this ICF recommendation letter, we have replaced these seats and we placed our equipments and covered this one. This is the arrangement we followed in the three-phase EMUs. This is before installation, driver backside the existing passenger seat. So, after removal of seat, as recommended with ICF, for installation of the Kavach equipment from driver cab side. This entry is from the other side. One more challenge we faced in the three-phase EMUs, Kavach DMI to be fixed in place of existing pressure gauges as per the RDS Railway Board's approved layout plan. That means here we have the existing pressure gauges available in the three-phase EMUs. Railway Board says that you shift this one here and you put the Kavach DMI in this place. So for this modification, Loco Pilot has put the objection for not to shift the available because they are versatile with this type of arrangements in the system. So initially we got the small hesitation. So this is the existing arrangement in the three-phase EMUs. These are pressure gauges. So we shifted these pressure gauges from here to here. This space vacant is used for the fitment of the Kavach DMI. This is finally we fit our Kavach DMI as per the railroad approved layout. So while coming to the WAP7, in the WAP7, space somehow we managed, but whereas putting of pulse generators over the axles, we face some different problem here. In WAP7, out of 12 axles covers, 4 is used for the motor earthing. These things are available arrangements. 4 for the motor earthing, 4 are obstructed used by the shock absorbers, and balance 4 can be used for the PG fitment. That means out of 12 axle covers, that means in each loco we have 6 axles. Each axle has 2 covers. So total we have 12 axle covers. In the 12 axle covers, 4 used for the purpose of motor earthing, and 4 are used for the purpose of shock absorbers, and 4 are left. In the 4, 1 is used for the locomotive PG application. That means only 3 are left for the Kavach PG fitment. So generally, first and last axles are prone for the wheel slippage. So that's why we are not preferring to put our Kavach PG into first and last axles. And one more condition is this: our PG should not be put onto same axle to avoid the common mode problems. So in other way, these are the 6 axles available for each locomotive. For each axle, we have 1 cover here, 1 cover here. Like that, we have total 12 covers. You can see for earthing purpose, 4 covers are used. Similarly, for shock absorber purpose, 4 are used. So 4 is left out of 12, 4 for the shock absorber, 4 for earthing. So leftover is only 4. So here in the out of 4, 1 thing is already utilized by the loco PG. That means 9 are already used by the locomotive and 3 are left. This is 1, this is 1, this is 1 left. So Our convention is this first axle and this first axle is prone for the wheel slippage. We don't want to put our Kavach PG into this axle. Our requirement says we have to put Kavach PG onto two different axles and that two different bogies. So our only leftover option is here, here, here. So here we selected this is the most appropriate one. We have elected this one, Kavach PG here. So one more is we are forced to put here or here. That means out of two Kavach PGs, one PG should be installed in the first axle or last axle. So what is our suggestion is we want to shift the existing Loco PG to first axle because this will not cause any braking application. Whereas our Kavach PG because of wheel slippage can cause the brake. So that's why shifting of existing arrangements to be considered by the Loco department to accommodate the vital Kavach PGs which controls the brake system. This issue is unresolved. We are coordinating with the Loco department. Next, we will go to other challenges. This is one more challenge we faced in the WAP7. That is intrusion of exhaust port towards our RFID reader clamp. Actually, this loco, even though this all the locomotives are of same class, some arrangements are different for different locomotives. Here in the right side, exhaust port is not obstructing our RFID frame. Whereas in one locomotive, our locomotive exhaust port is obstructing towards RFID reader. So that's why the local element they have cut this one, and later they have come up with some customized solution, this type of things. So this is overcome like that. This is the underframe arrangement. This is the CBC coupling. This is the cattle guard. This is our Kavach RFID reader. In the right side, you can see our exhaust port is not obstructing with the RFID reader frame. But whereas here, this exhaust port is protruding towards RFID reader frame. While coming to one more challenge, poor workmanship. This is the Fevely type brake system as part of Kavach system. As part of Kavach system, we had to remove one item and we had insert our light engine module of Fevely here. After installing this one, we had to tighten the D2 relay valve. Here, in one installation, over tightening of D2 relay valve has caused the damage in this equipment, D2 relay valve. So we suggested that instead of using normal wrench, we had to use the torque wrench to avoid these type of equipment damages. So these are the challenges we faced while doing the installations. Next, we will see general challenges. And out of our experience, what is our suggestions? Individual loco survey is compulsory despite of having approved fitment layout diagrams. That means even though RDS has given approved layouts for the WAP7, WAP4, space is not available. Some space are available occupied by some other applications. One example is HOG, head-on generation. Presently in all WAP7, head-on generation works are going on. So this nominated space is occupied by head-on generation. That's why whenever we are going for the Kavach fitment, we are waiting to complete HOG work. After completion of the HOG work, we are taking up our Kavach works. Similarly, for installation of EMUs, we require 110 volts DC operated solenoid valves. Whereas 24 volt DC is conventional, 24 volts DC valves are required for the conventional locomotives. That means for going for the EMU, all these required materials should be procured in time. Next one, limited or single source of procurement of BAUs. Let us say for CCV type of locomotive, we have to buy BAU only from the North Bremse. For E70 type of electrical locomotive, we have to buy BAU only from the Fivili. For getting this type of BAUs from these OEMs, the minimum lead time is 6 months. So this is causing delay. Next, these BAUs will be consigned inspected by the loco shed officials. So for procurement of these, we have to get shed official nomination. Then that SSC should go to the concerned OEM premises, having the test setup. So RDS inspection in this case may expect the project execution. In addition to these challenges, HHP locomotive. We have not installed any KAVACH into HHP locomotive. The one more approval we are waiting for the RDSO is speed sensor arrangement in the HHP locomotives and modification end cover for the PG installation. Here, you can easily guess for putting off our PG, the existing installation is obstructing. So, we are awaiting RDSO approval what type of PG we have to put for this type of locomotive arrangements. Other one is RDSO approved loco fitment plan for onboard KAVACH for diesel locomotives is awaited. So next, while coming to conclusive part, what Zonal Railway should take care? Zonal Railway should ensure RDSO approved braking characteristics and fitment plans for the consent type of locomotives to be equipped with KAVACH. That means after completion of this fitment, RDSO will do elaborate trials with different types of coach composition. That means one light engine trial and 5 coaches, 10 coaches, 15 coaches, 24 coaches, ICF. Similarly with the LHV coach compositions, RDSO will conduct the rigorous trials. After completion of these trials, if test results are satisfactory, then they will issue the approved loco manual parameters. Based on these parameters, we can feed these parameters into Loco KAVACH and we can run these locomotives with the operations. This is elaborate and laborious work. The summary, the progress of the various OEMs and loco type approvals listed here. While coming to Kernex, WAG7, WAP4, WAP4, WAP7 and conventional EMU and all types of Alco diesel locomotives completed. Only pending with Kernex is 3-phase EMU. Trials completed. Approval is expected within a week's time. Similarly, if you see the HBL, except WAP4, approval for WAG7, WAP7, conventional EMUs, 3-phase EMUs, Alco diesel locomotives have been completed. And for WAP4, initially it was not into their scope, fitment into WAP4. Later RDSO decides that HVL to install their KAVACH into WAP4. So they have completed their WAP4 and trials also completed today. And within a couple of weeks, we expect that RDSO approved parameters for WAP4 of HVL. While coming to measures MEDA, except WAP7 and WAP4, all other types of locomotives, WAG7, conventional EMUs, 3-phase EMUs, Alco type of diesel locomotives, they got the RDSO approved parameters for locomotives. While doing the execution to Loco KAVACH, RDSO also suggested few more improvements. That is, reduction of the radio RFID reader height from 550 meters to 450 meters from the rail level to prevent the adjacent tag readings. In the initial days, we used to get the wrong readings from reading of the tag from adjacent track and applying the emergency brakes. To avoid that one, RDSO suggested that reduce the RFID height reader from the rail level so that that radio beam also will be reduced. The scope for reading the adjacent tag will be reduced. Similarly, the existing 0 dB gain RF antenna available in the locomotive to be replaced with 3 dB gain wideband antenna. Third improvement is existing RF antenna cable and its routing to be changed to shortest path with LMR 400 cable. In the initial days, due to lack of experience, we used to have LMR 200 cabling inside the locomotive. Now, RDSO suggested that only go for the LMR 400 in the locomotive, LMR 600 in the stations. GPS, GSM antenna cable routing to be changed to shortest path to improve the signal strength. In the initial phase, we have installed locomotive with single pulse generator. Later, RDSO suggested that Kavach equipped loco shall be installed with 2 quadrature type of directional pulse generator to achieve the SIL4 orometry function. Similarly, SIMs also, dual SIMs to be provided in Loco Kavach for effective functionality and proper update of the KMS keys. These are the few system improvements suggested by the RDSO, and we are following the project 2 and also corrected in the project 1 locomotives also. Recently, one more session RDSO given to Gigitonics, upcoming vendor after MEDA Connect HPL. So they are putting, instead of the vertical direction, they are mounting their RFID reader. In the conventional method, we had to install in a vertical direction. This is the RFID reader. We are installing into vertical direction. Whereas in the new version, RDSO suggested to erect into 30 degrees version. Okay. The purpose is with this, we want to reduce the reading of the unintended tag. So this installation is completed in the field, and we have test. In a couple of days, we will test in the field also. We will see the efficacy of the system. This is one more system improvement we have done in the field for installation purpose. So with this, as I already informed you, we had 2 projects. In the first project, we are doing 1200 kilometers. As part of 1200 kilometers, our scope is 160 locomotives. And the previous project, that is project 1, our scope is 40 locomotives. This is a 40 locomotive bifurcation for different vendors and different types of locomotives. As part of the 1200 kilometers work, out of 160 locomotives, almost 130 locomotives have been installed. This also includes one more project, 86 kilometers. So this is a developmental work given to Gigitonics and Quadrant. As part of developmental work, installation in one WAP7 locomotive by Gigitonics has been completed, and with that tilted mounting of the RFID reader, we had tested this one to field. So with this, we have completed 131 locomotives in 1200 to 86 project and 40 locomotives into 265 kilometers work. Altogether, South Central Railway, we have 171 locomotives completed with Loco KAVACH. These are the different types of locos we installed. So one more good thing is, in the Maulali EMU car set, all 35 EMUs, conventional EMUs have been fitted with KAVACH. While coming to 3-phase EMUs, out of 12, 10 has been completed, and the balance 2 will be completed by Gigitonics and Quadrant. With that, all 47 of conventional EMUs and 3-phase EMU will be fitted with KAVACH. Actually, we had taken this decision consequent to the accident happened at Kachiguda. One EMU and the November month of 2019 year. After that, we want to change our scope from locomotives to EMU also. So with that agenda, under SARS guidance, PCSR guidance, we have completed almost all the stock available with EMU car set Maulali. This is our population of the equipped locomotives in Southern Railway. Which is summary, loco wise. So out of these 171, we have 61 diesel locomotives and 65 electrical locomotives and 45 EMUs. Altogether, it is comes to 171 locomotives. After completion of installation, our main agenda is utilization of these KAVACH locomotives to get the maximum benefit out of the KAVACH system. So in this regard, we have prepared one pocket handbook and we have given training to the loco pilots. These are the sample loco pilot handbook given to them to quickly recap issues of KAVACH. Almost 4,000 to 5,000 copies we have prepared this one, and whenever we are conducting the KAVACH training to loco pilots, we are distributing these loco handbooks to all of them. So this is the training schedule, training given to the LPs. We are mainly focusing on 4 divisions. First one is Nanded, Hyderabad, Secunderabad, Guntkal. So to cover the maximum number of LPs, our idea is to focus mainly at ETCs and DTTCs. So Vijayawada DTTC and Guntkal DTTC, Vijayawada ETTC, we are focusing. In addition to this, at Nanded, as per the special request from the Nanded Senior DME, we are monthly classes conducting at Nanded, Purna and Aurangabad. With this, almost nearly 3,000 LPs we are covering as an initial training to them. Our main aim to conduct these things is the system should be under utilization to get the benefit of the system. So spat should be avoided, action should not be happened. So for this agenda, what are the interagency dependencies to implement all this mission? So here we have to regularly coordinate with these type of officers. First one is RDSO, as I explained, for getting the approved parameters, braking parameters, fitment plans, and approval of application safety cases, equipment approvals. We are depending on the RDSO. Similarly, for CLE and CSC, CMP, diesel, these 3 officers, CLE mainly for the electrical locomotive, he is in charge for the electrical locomotives. For fitment into electrical locomotives, we have to get the approval of CLE. Similarly, for the diesel locomotives, CMP diesel, CSC, he is electrical officer reporting to TCME sir. For fitment into EMUs and memos, we need coordination with the CESC. Similarly, while coming to CE operations, after your installation is completed, the equipment should be switched on and should put into the operations. So for this, we have to get some instructions from CEOP. All the LPs and the senior DEOPs are reported to CEOP and planning. So we are regularly coordinating with the CEOP for switching on these type of KAVACH fitted equipments and getting their feedback. This is the role of the CEOP, and training sections also, as per the requirement and directions of the CEOP, we are arranging this LPs training at all the DTTCs, ETTCs and crew lobbies while coming to CTM and CPTM. So for making of GNSA corrections, SWR corrections, getting these rakes for testing and feedback and TCAS wiring, we have to daily interacting with the CTM and CPTM officers. This is a multidisciplinary project. This requires heavy coordination across the different departments of officers. So after doing all these things, what are the required documents? Everything we, in a companion manner, we have in a single place, we have archived for easy reference for others. These are different guidelines we have collected and also available in our RDSO website also. Link is given at the bottom. For guidelines, responsibility among different branches, RFID, fitment plans for different locomotives, braking parameter, everything is available in this compendium. It's an easy reference for you. That's all about the presentation regarding the KAVACH fitment and the challenges faced and solutions. So anybody has any doubts, we will clarify one to one.
You can see the questions in the chat box.
Yes, sir.
Manikumar, please switch on your video and reply the questions, whatever is there in the chat box. And participants are encouraged to ask
Yes,
direct
sir.
questions if they have not already placed in the chat box.
Sir, I'm just reading, sir, one by one. First query from the big Agrawal, sir. Is it being ensured that all KAVACH works are being executed to suit RE standards? Sir, yes, sir. Actually, regarding this RE query, sir, I have only a small portion left over, that is between the Parli to Parbani. So only that also one location, sir. It is not a general statement, sir. It is a location specific observation. You made it, sir. And we are also ensuring, sir, proper earthing and suit with RE standards only, sir.
It's not just about earthing.
Sir.
My query is also regarding
Sir. Yes, sir.
relays, wherever required external relays to be humanized. Also regarding RE cutting, if length of the cable circuits used is more than 2.8. It's a collective, it's not just specific to earthing of the armor.
Noted, sir. Sir, once again, I will check it, sir, because on this aspect, we'll give focus and we'll come back with complaints, sir.
Then
No, it is not a focus. First of all, Manikumar, you have to basically
I'll
review
explain you,
drawings.
sir. Sir,
Sir, actually, Rao sir wants to explain something, sir.
Yeah.
okay, sir. See, in RE, what all the requirements, what we are doing in RE section, converting from non-RE to RE, like that here also we are taking care, particularly the tower earthing and all. Then whenever we are using only the OFC cable, which is more than 2 kilometers to connect RE at LC gate to station taker. All those things we are observing. Moreover, all the relays, what we are using is QNA1 whenever we are using in the location box, which is generally is not here except at small LC gates. Very around 14 in this case is available, particularly in the another division. Otherwise, from the relay room only we are taking. So all these inside repeat relays only we are taking and we are giving inputs to the station takers. So there is no much requirement in the inside the area. Externally, we are using OFC cable, so there is no requirement as such in the length of the cable and RE. Except existing cables where we are using for spare cables are already available in the from LC, nearby LC, say 1.5 kilometers or so, or around 2 kilometers, 2.5 kilometers, which is in the RE area. Those things we are taking care, which is less than 2.5 kilometers. Not so nahi hota hai, but generally we are taking care of RE standards also. We are not having more than 2 kilometers as such. Otherwise, the tower will go. And the tower itself, we are having lightning and earthing arrangements and proper ring earth arrangements also. Again, we are connecting from the top of the tower from lightning arrestor up to bottom. We are putting the strip apart from measuring earth measuring arrangements in all the 4 legs with the connected source only with the fronts. All these things are
Correct. My only request is, can we, like in RE, we have a standard checklist has been made. Can we have some small checklist for TICAS also specifics where this
exactly.
item is to be?
Yeah, here in this case, we have been yesterday evening also we have discussing with PCHC sir. We have already prepared a checklist for all the particularly 34 stations of HBL. In that, what are all the equipment like TASA, same compliance we are supposed to give it here. This particular RE also we will keep it as per your recent letter. We will take care of that annexer also in this case. This is another good suggestion, sir. We will take care of RE compliance also as one of the certification to be given before deploying into the system. This will take
And,
place.
and now every installation should be to suit RE, because only Indian Railways decided to go for 100% electrification. So whether there is RE or no RE in that area, it has to be done to suit RE.
Yes,
So,
sir.
BK, just be specific, because Mani Kumar was mentioning about some location at Parbhani. So, what was the observation?
Sir, in that location, there was a cable laid from LC gate to station, and these signals were being repeated on that cable, and that cable had cutting it every 500 meters. Location box, it was terminated junction box, but there was no earthing done to the boxes or armors.
Okay.
For question also just now.
No. What we can suggest now, based upon this experience and observation, 2-3 actions are required to be taken, which Mani Kumar can take into note it. First of all, our all drawings, there must be one note that the entire installations is suitable for 25 kV electrified area, like what we write in our signaling drawings. Number one. And it should be all drawings. Let us not discriminate with the indoor and outdoor. The second thing is that let us make out a checklist. Based upon the checklist for the entire installations, what we are using for RE modifications, let us review those checklists, and whatever is applicable for the TICAS installations, let us incorporate those items and make out a say 1 page or 2 page checklist, just to have the confidence, and then after of course certification basically. So these are the 2-3 items required to be undertaken in all our, even the as-made stage also. I hope it will suffice.
Yes, sir.
Noted, sir. Yes, sir.
Sir, what we'll do, sir, quickly we'll see this checklist format, and then we'll incorporate as a part of this documentation what we are going to submit, sir.
Yeah.
For
Exactly.
your PCST's sanction as well as site visit, sir.
Thank you.
Next question.
Yes, sir. I will go to next question, sir. Sir, basic difference between the GSM and GPS. In the downside, they explained that GPS antenna is used for the location, time synchronization with station TICAS. GSM is used for the updation of the keys from the KMS server to local TICAS equipment, sir. Next, while coming to the next question from the Chandrasekhar AST Secunderabad. IRAB abbreviation, please, sir. IRAB means Indian Railways Air Brake System, that is available in the conventional locomotives. Next from Raghavendra, based on type of loco, what are the cab inputs like BL1, BL2, outputs RN1, RN2, traction cutoff, NSB, FSB, FB, feedback that we need to consider. Actually, in the bottom line, from the GS has replied, sir, that what are the inputs we will take for the cab inputs. Next, what are the safety measures taken against hacking or tampering of the system? Sai Krishna from STC, it is regarding the communication hacking or physical tampering of system. Can you repeat, Sai Krishna?
Sir, both, sir.
That means one is through cyber security, other one is physical tampering.
Yes, sir.
Okay. So actually this hacking will be taken care by the safety keys, safety encryption available in the our COS system. That means KMS, session key, encryption techniques are there. With that, only authenticated members can only will interchange the information. Third member cannot enter into the system without these authenticated keys. This is one time. Other tampering of system. This is similar to our loco equipments. We are handing over to the loco shed people while handing over. So this would be the responsibility of the shed along with other assets of the loco.
Okay, sir. Thank you, sir.
Thank you, Sai Krishna. Other one is
But Muni Kumar, the issue is having far-reaching repercussions than what you are conceiving and what we have already conceived till date. See what happens. Encryption, although the professional hackers are able to decode the encryptions and hack the system. It is not that the whatever system is hacked or attacked is not having the encryption techniques. We are having encryption techniques, but it is of what standards. The issue is this, and unfortunately, the problem is that it is not only the Kavach system. Any system which is available in the Indian Railways, we have not paid sufficient heed to this threat. Although the railways worldwide who are using even totally in-house system, they are also taking care of a lot of things. So I think we have to work on this, and we have to basically make some kind of first of all understanding that what kind of threats can happen, and what are the basically attack points on which this can happen. And the second thing would be that we have to use the services of the professional cyber security experts, because see ultimately we are having something for our we are using some help of this GPS system, GSM. So all these things are basically open to everybody, and they may be the potential point of attack. So in fact we have to get it comprehensively, I think, audited for the cyber security threats. And this is an area which is required unexplored and is required to be explored.
Yes.
So this is a very good question, and I'm really happy with the kind of inquiry which has been put, and we will work on this. Let us work on this.
Sir, yes, sir. Noted, sir. Sir, in this regard, sir, one railway board team, cyber security team, reached our Southern Railway, sir. They studied preliminary things about Kavach. We have small meeting with Venam Rao, myself, and Reset also, sir, regarding Kavach. And it will be under pipeline, sir, regarding the same security threats, how to avoid all those things. Just 3 months back, one meeting happened, sir, in the reset. Some team has come from the railway board, sir. I will update
We have
further,
to
sir.
follow up about their observations.
Yes, sir.
What observations they have made? Have they referred this issue and this entire system to some cyber security experts for the auditing? Because I think that the team was not involving some experts in the field.
Yes, sir.
So we have to take it forward.
Yes, sir. So the other question, sir, why tower height is maintained at 40 meters? Is there any limitation? In case of increasing tower height, will increase the range beyond 4.5 kilometers. So in the project 1, we only installed 30 meters tower height. That is just sufficient for our double distance territory. But to avoid intermediate packet losses, RDSO suggested to go for the 40 meters height. That's why we are going for the 40 meters height. And is there any limitation? But they mention minimum height is 40 meters. There is no limitation not mentioned in the RDSO specification. In case of increasing of tower height, will increase the range beyond 4.5 kilometers. Yes, if you increase the tower height, range will be increased. But one more thing is, in the future, we are going to LTE of 700 megahertz. That is also a factor we have to consider while taking care of the tower height. Sharon, is it okay?
Sir, okay, sir. Thank you, sir.
So one more question from, is it fail-safe system? Yes, this is complied with SIL4 standards. It is a fail-safe system. Is there any other doubts from anybody? Will clarify.
Muni, I have a question.
Yes, sir. Yes, sir.
What if when we start putting TCAS to a regular use, why should we not enforce that The drivers cannot change it to that mode what you call
Full supervisor mode, sir. Kavach mode.
From full supervisor to
Staff responsible mode, sir.
staff responsible. Yeah. See what
Yes, sir.
I'm just simply telling you. See what happens to locomotive. If a locomotive fails in the midsection,
Sir.
if it is not possible to repair, don't
Yes,
we
sir.
send a relief loco and bring it back or do something? Because if they are putting it in the staff responsible mode, then
Sir.
it is not a fail-safe system at all. It does not remain fail-safe anymore. If you are running any locomotive or any vehicle without Kavach in a Kavach territory,
Yes, sir.
I would say any vehicle, even like Speak, we also have a car that is called Speak, self-propelled inspection car.
Yes, sir.
Are you planning for putting Kavach on that also?
Sir, yes, sir. Sir, actually, two more proposals come, sir. One is SPIC, other one is our engineering machine, sir. CE, PM
Engineering
has
machines
also.
also, yeah.
Yes, sir. Engineering machine also, sir.
Tower wagons also.
Tower wagons, yes, sir.
Yeah.
So, in the due course of time, sir.
Point what I want to tell you, anything in the Kavach territory which runs without a Kavach is a potential threat to others which are running with the Kavach.
Correct, sir. It is underutilization system.
It does not remain a fail-safe system anymore.
Yes, sir. Correct, sir. So, system should be underutilization, sir. Even though we spend a lot of money and we are not operating, putting into off condition, not yielding our output, sir.
More than not utilizing, I'm more worried about the creating unsafe situation.
Yes, sir.
Yes.
Correct, sir.
No, I think COE is also available in the audience.
Good afternoon, sir. Yes, sir. Shall I address this query,
please,
sir?
please.
Good afternoon,
please
everyone,
light
sir.
on this.
Yes, sir.
Last question, please.
Yeah, last question also we'll take up, sir. First, what BK Agrawal sir has told, regarding fail safety of the system, sir. Here, I would like to just mention, sir. Actually, suppose some onboard equipment which is not equipped with TCAS or Kavach equipment that cannot apply the brake. So that way, it is really not able to prevent SPAD because there is no Kavach, so no brake application will take place. However, I will just give you one example. I think, yeah. I'll give one example. We had erstwhile one system ACD, anti-collision device, that we used to consider as unsafe. I will tell you why. Because on 26th December 2012, one accident had occurred in ACD territory, in which one of the trains involved, light engine was equipped with ACD, but from other side another passenger carrying train was coming in Lido Dibrugarh section. You can Google also, this is mentioned on Google also. Head-on collision took place despite fitment of ACD in locomotive, which because it didn't have capability of cab signaling or prevention of SPAD, so that head-on collision took place. CRS report also is there. Whereas in case of Kavach, what would happen, sir? Like suppose block section is occupied with, let us say, block section or any other particular section is occupied with a non-Kavach equipped rolling stock. Then, because Kavach is overlay on signaling system, it is not standalone system. It is overlay on existing signaling system. Existing signaling system will not allow any signal to be taken off for that line which is occupied, whether it is block section or any other line. So movement authority will not be granted, and by means of SPAD prevention, this particular train which is fitted with Kavach, those trains which are fitted with Kavach will not be permitted to approach the other train. That is one part, sir.
In case of BLCT block failures, what will happen?
Yes, sir. Yes, sir. I will tell you, sir. In signaling interlocking, also we say it is fail safe and it is SIL4. It is compliant to SIL4 function. In interlocking, also we have got signal failures. In that case, we have got manual procedures are there. Station master has to follow some procedure. we cannot say because signal has failed, that is why it has become, that's why interlocking is unsafe or signaling system is unsafe. Engineering systems are bound to fail, sir. So whatever in case of failure of engineering systems, we have to follow certain procedure, manual procedure. So that should be defined. For example, in Kavach also, suppose communication is not available, or let us say due to some problem, it is not able to generate authority. Then what will happen? It will prompt the loco pilot first that I am not able to provide protection. I am not able to supervise. If LP or loco pilot or train pilot responds by acknowledging two buttons, okay, then that event will be recorded, and it means driver has taken cognizance that now system is not able to provide protection, so it will enter into staff responsible mode. So that requirement is sufficient, sir, to call that function as fail safe. And if in case station that loco pilot doesn't acknowledge, doesn't notice this, then automatic application of brake will take place.
But here, sir, the title of our technology is TCAS, Train Collision Avoidance System. That means the objective of the system is to avoid collisions.
Sir,
Are we meeting that objective 100%?
if all the rolling stocks are fitted with equipment, then yes. If not,
Fitted,
then certainly we cannot have, no, sir. When equipment is not there, it cannot have automatic application of brakes, sir.
No, even with equipment fitted, if it is working, allowed to work in staff responsible mode.
Sir, these are degraded modes. As I told, sir, in station interlocking also, suppose during manual piloting, signal has failed. Some train is already occupied, let us say loop line number 1, and station master by mistake routes or pilots the train to same track, then collision will take place. Similarly,
Agree, sir.
in this also, sir, in SR mode, means responsibility lies with loco pilot.
Correct, sir. There we declare that if our signal, if it comes, no problem. If it doesn't come, handle it manually. So interlocking never fails. But here we are telling a system, we are giving a system in which no collision will take place.
No, sir. Here also SR mode means supervision is not there. That is why there are some modes: full supervision, limited supervision. Staff responsible mode means driver has to drive the train cautiously. Sir, shall I come to other query, sir?
Sir, yes, sir. Yes, sir.
Sir, first of all, PCST sir has very nicely addressed about requirement of going for enhanced cyber security. That is very much need of the day, because even if we provide some security measures, day by day we are finding the processing power of available with hackers also is increasing. So anyway, we have to see. So presently, what is there in that? I will just elaborate a little bit. As Monikkumar told, there is provision of authentication key. Key management server will transfer the authentication keys with validity, defined validity, expiry, and commencement to various entities in the network, and authenticated entities only will be able to communicate, but authentication key is not the only protection measure. These authentication keys will be transferred in the same manner the way back we are getting transactions with banks, OTPs and all. So apart from that authentication key, there is another mechanism also in which suppose one locomotive goes to different stations. So encryption will be different. What I'm trying to say, there will be one session key in which authentication key will of course be one of the functions. Apart from authentication key, there will be some more items. Like one train going to different stations will have different encryption. One station having different trains, many trains at one station, all the train with the station will have different session key and different encryption. So altogether, if we calculate the probability of causing sabotage even by the designer, that is well below the requirement, well above, rather I should say. It is better than the requirement which is laid down in Senelec norms for the like 1 into 10 raised to power minus 8 tolerable hazard rate per hour per function for this communication. What I'm trying to say, the communication has been assessed and found fail safe at the moment, we can say. And cyber security team which had come, that was joint cyber security, railroad and outside experts also. That also, after thoroughly going into it, and later on communication with correspondence with us, VNM Rao and Muni Kumar, they have found that at present this is reasonably fail-safe system. But of course, as PCST sir has told, we will further see this, that how it can be further enhanced security level. Now, sir, Muni, you would like to address this question? Hyderabad Metro used CBTC and present CBTC, or?
Sir, no, sir. In fact, I want to request you, sir. You can better explain this question.
Okay.
Yes,
I'll tell you. Actually, I'll tell you. See, CBTC is basically based on IEEE 17. But actually, see, I'll tell you. Communication based in control, or CBTC, is basically used in metro kind of environment in which the traffic is captive. And invariably, we are finding that the ground equipment and our onboard equipment both are from the same OEM. Train control system at the ground and train control system on board, both are from the same OEM. So proprietary protocols are used in that. You can well appreciate that when we have to acquire same level of safety, it is very easy to get in, let us say, BPSC, which is there on the cable. Both the Excel counter units are connected on cable, so it is very easy. With metro type of environment, it is little bit difficult because it involves radio communication, but of course it is proprietary system. When we come to mainline train control system like European train control system, ETCS, or for that matter TCAS or KAVACH, protocols are open. So in order to achieve same level of security or safety, we have to give a little bit, more, we have to take more security measures. So as I told, both are actually different. CBTC is in ISM band. It is 2.4 gigahertz. In Hyderabad Metro, in fact, a couple of days back, I had made one visit also. And actually, there what they do, there is zone controller. Zone control is nothing but, it communicates with the WRU or units. You must have seen at metro stations also, they are providing antenna or radio on the masts itself, which is covering around 200 meters distance. So range is less in Hyderabad Metro. At the same time, communication is proprietary, and it is in a non-licensed band, in nutshell. In KAVACH, it is not like that. It is radio coverage range is quite more, even with present communication backbone, as well as what we will be having when we integrate with LTE or 5G. And of course, security, radio security measures are better in KAVACH system. At this moment, I can tell this, otherwise it will be too lengthy. That STTC can ask separately also. On this, we have got presentation also on this. Muni Kumar, next.
Thank you, sir.
Yes, sir.
Next,
Thank you, sir.
next,
Thank you
next
for your
query.
explanation, sir.
Next
Yes, sir.
query, you can take up, and if
Any
you wish, I can.
Yes, sir. Yes, sir. Any mechanism in order to detect the failure of KAVACH. Generally, sir, we are using two kind. One is NMS one, other one is failures reported in the CMS. These two mechanisms we are using as a detection of the failures. STTC, okay, it is. Srinivas, this doubt is clear?
Sir, good afternoon, sir. Srinivas.
Srinivas, this doubt is, you got the answer or not?
Satisfied.
Any mechanism involved to detect the failure of KAVACH?
Sir, I'll tell my question. What is my doubt? See, suppose, for example, the driver is approaching a danger signal.
Okay.
Suppose it is that, for the purpose of discussion, I'm telling, suppose that KAVACH has failed in face
KAVACH
of
has failed.
danger signal. So is there any
KAVACH
mechanism to detect that KAVACH will definitely fail in applying the brakes?
Srinivas, your voice is a little disturbed. Please repeat the question.
So suppose, for example, the loco pilot is approaching a danger signal.
Okay.
Suppose it is likely that the KAVACH will not apply the brakes because the system has failed.
Okay.
It will not apply the brakes. Okay, for the purpose of discussion.
Okay.
So is there any mechanism to detect that the KAVACH will fail to apply the brakes? Before only.
So, okay. So what are the precautions we are taking? That I will tell Srinivas in other way.
Sir.
Initially, first we will test the type of locomotive with different coach combinations, and accordingly the braking parameters will be set, right?
Okay.
And those braking parameters will be approved by the RDSO. This is first step. Second step is these approved parameters we will load into system,
Okay.
and we will do one or two spads whether it will apply the brakes properly or not. In addition to these elaborate procedures, we also do for one loco, for one type of loco, one time we will do it. Okay, so that means we'll test at one location, one SPAD happened or not, SPAD prevented or not. Similarly, PSR is followed or not, loop lane speed control is done or not. These three checks we will do it, and we will take the site acceptance for that particular loco.
Acha.
Okay, that means once the software is same and the checksum is fixed, then we expect that it will deliver the same performance. Just like EA, some software we loaded, we check the checksum, we see the relay room.
Okay.
Correct. So in that way, we'll ensure this one. This is the ensuring mechanism we have.
Not erase you are selling, sir.
No,
Yeah, yeah.
Muni Kumar,
Sir.
just let me ask on behalf of this, I think Srinivas or whoever is there.
Sir.
His question is very different.
Yes,
His
sir.
question is, the Kavach equipped train is approaching the danger signal.
Yes, sir.
On or split signal. ठीक है ना?
Yes, sir.
And Kavach has failed to apply the brake.
Yes, sir.
Our system has failed.
Yes, sir.
What are the protection mechanism available to reduce the risk, basically mitigation of the risk in this case? Question
Okay,
is very.
sir.
I hope this is the Srinivas. This is your query.
Yes, sir. Yes, sir. Correct, sir.
Yeah. So you please reply this one. There is no need to explain the mechanism of finalizing the braking characteristic and other things. Let us assume this scenario, what he is trying to explain, and reply.
Sir, we are,
Kumar, can we help
Yes, sir.
myself
Please,
or
sir.
Nagaraj?
Yes, yes, sir.
Sir,
Yes,
sir,
sir.
Nagaraj, sir, can I add, sir, something?
Yeah, Nagaraj.
Sir, in this case, in every startup machine, what we have is a brake. Whenever we set the configuration and you bring the machine from isolation mode to normal mode, then the working of brake system is tested by the system, sir. So physically, the Kavach will initiate braking through Kavach interface available, and whether physically braking is brake pipe is getting discharged or not is being physically verified, sir. Then only the system will take into successful mode, and then further mode transition is possible. That is the first mechanism, sir. Second mechanism is that sometimes we may have maybe some improper details of gradient or something. We may have late intervention which may cause the signal to pass or something to happen, sir. Otherwise, as on date, there is no mechanism in between to check whether the brake continuity is there or not. But
Nagaraj, just let me add, Nagaraj. Srinivas.
Sir, I'm listening, sir.
As Nagaraj told, like at the start of mission, like at the beginning itself, when the loco Tikas is booted. Okay, when driver is starting the train, at that time, physically, pressure is discharged through Kavach unit at the boot up during boot up. This is done like when the pressure is discharged in BP pipe and BC is built up, and through that means it is checked whether the braking system is intact or not. This is to reduce the probability of missing, not functioning of brake interface at later stage when the need arises. Initially itself, suppose train is coming to Kavach territory and it has been already, after so many days it has been booted up. So it will simply check whether BIU is intact or not. If suppose beginning itself there is some problem in the brake interface unit, train will not enter into full supervision, means supervision mode, and it will tell ki I am not able to work properly. Driver has to drive in on responsibility. That is one point. Another thing, when we approaching to signal, I will tell you the design is something like that as we do in our signaling circuits. What is done like normally final feeds, which were I'll tell you that actually whenever brake is to be applied, basic funda is like BP is to be dropped, let us say, or BC to be built up in light engine. So in our circuits also, what we do, we will take pickup contacts, isn't it? So here also I will tell you, there are some valves. Those valves remain energized as long as BIU is functioning properly. So BP pressure is maintained only when BIU is functioning properly. As soon as there is any problem in the brake interface unit, okay, then what will happen? That particular, you can consider equivalent to your HR relay. That relay will drop. Okay, so something that like that, there is pneumatic and electrical arrangement both in series. So as soon as there is any problem, this BP pressure will get exhausted. What I'm trying to say, the health of the BIU is being continuously monitored by different means. And whenever there is any, this is very basic fundamental, requirement for any fail-safe or SIL4 system. And this has been thoroughly gone into by ISA also. And whenever there is any problem, the TCAS driver will get the prompt that there is some problem. So you have to take into staff responsible mode or standby mode, and then fail safety will be ensured by that means. I hope that is clear.
Okay,
Srinivas?
Okay, sir. Continue, sir.
Yes, that is what. So there is mechanism to keep on monitoring the health of BIU, and in case of any problem, BP will drop.
In that case, it's fine, sir.
No, just in continuation to this question, there is one question from Nagraj, because he's available and he's a loco expert. Can we say that because as per the present practice, whenever a new crew take over the locomotive, he is supposed to conduct the brake field test. Is there anything similar available in our system or in our operation manual, what we have already given to loco pilots?
Sir, at present only the start of mission only that MBT is done, sir. But that MBT possibility is there, sir. Manually also we can initiate, sir. But at present that practice is not there. Only at the start of mission, when we move from isolation mode to normal mode, system automatically initiates that manual brake test, sir.
Okay, but in operating manual, whatever has been given to the loco pilots, is it appearing?
That is automated in the KAVACH system itself. So the moment we operate the car from
see what happens when the, say for example, KAVACH system is functional and the loco pilots has taken over at intermediate stage. For example, let us say at Vikarabad, crew changeover point is there. Crew change point is there, and another crew comes. How we get the confidence? Because as per the rules, he is supposed to conduct the brake field test. So what is the assurance we have given from the KAVACH side to the loco pilot that an equivalent of the brake field test is available?
we need to check the operating manuals and get back to you, sir. What exactly is
Yeah.
But
And plus, moreover, you have to check one more aspect that if suppose the system is full supervision mode, then should he treat it as a completion or conduct of the brake field test? If have we incorporated any such logic, then let us
that is there, sir.
revisit this.
That is there, sir. Whenever all the isolation cups are open, and second thing is manual brake test successful, then only further transition into modes into full supervision is possible, sir. So that aspect is taken care. But every time when the crew changes en route, when already locomotive in full supervision mode, whether any provision for intermittent manual brake test is available or not, that I have to see, sir. But I will look into it, sir.
Yeah.
So next question is from the senior DST Bejawat Vishnath. Any maintenance practice has been standardized for loco TCAS maintenance, as the locos will not be at a stable location, unlike our conventional signaling system, which will be located at a fixed location. Vishnath, as per the RDSO standard guidelines issued in the form of maintenance sheets, they're saying that after completion of 3000 route kilometers, the loco will come back to the trip shed. There you do some preliminary maintenance. Again, after 1 month, it will come back. Then you do. That means we are doing the maintenance only at the sheds, nominated sheds, after completion of their fixed schedule as per the RDSO guidelines.
No, but any schedule is
Yes,
there.
sir. Schedule is yes, sir. Clearly, schedules are maintained, sir. First schedule is after the.
No, listen first.
Sir.
There are two schedules because before coming to the homing shed, the loco at intermediate stage go to the trip shed also.
Sir.
Do we have this facility at the trip sheds? I think no.
Yes, sir.
Because trip shed we are not having the maintenance engineers placed. Our maintenance engineer placed only at the homing sheds only. So this is a very good question and eye opener for us, that we have to look our maintenance schedule periodicity, that if any periodicity is there which is less than the time period before the upcoming after which the logo comes to the homing shed, then in that case we have to make the arrangements. This is a very nice question. And I think we have to revisit our maintenance schedule periodicity and see that all maintenance schedule prescribes are only at the homing shed, not at the trip shed, because we don't have any arrangement at the trip sheds.
Noted, sir. We'll go to the next point, sir.
Before that, sir,
no, thank you for that question.
Sir, we will refer to RDSO and we will write to COE also, so that we will give some guidelines on this. What are all the local sheds during the IOH and POH schedules at the home sheds particularly? This aspect was not covered actually, not thought was also not necessitated. Now we will work into it, sir.
Sir, in addition to that, sir, actually, that whatever that 3,000 kilometers is, it is kilometer basis, sir. But our schedule is time basis, sir. So the 3,000 kilometers, it may not sync with our timely periodicity of maintenance schedule. That has to be thought out, sir.
Actually, as on date, only trip schedules are kilometer based, sir. Major schedules, IIT, IC are time based only, sir. 90 days, 180 days, like that for different locomotives. So most of the maintenance only during trip shed, only visual check is also being done at the locomotives also, sir. There is not such, only they will charge the battery and then that electrolyte levels, like that very primitive maintenance is being done, sir. Anyway, we will also look into this issue, sir. What exactly to do.
So Nagraj, there is another issue, another aspect of this, because there is a very frequent phenomena of extending the validity of the loco. Okay, it happens left and right, and as per the last safety VC review which has happened with the board, it has been told that almost 45% overdue locos are running the system. So if that happens, what is going to happen with our cover system? So we have to give a thought over this also.
Noted, sir.
Yeah. Please go for the next question.
Yes, sir. Sir, is there any event storage device installed in the DMI, just like black box in the aircrafts, so that we can retrieve the data after any unusual things happened? Sai Krishna, we have some data logger kind of thing installed in the our Locoticas that we call it as ideal internal data logger. So with this, we are downloading all the logs pertaining to logo and we are analyzing the failures. Sai Krishna, is it okay?
Okay. I think any crash of aircraft will be secured, sir. But in the event of any accidents of locos, is that that's my question.
Actually, similar to black box, not available, but similar to our data logger, logging of all the events is available, and we are downloading the events on that ideal only of the Locoticas.
Okay, sir.
Munikumar, it will retain the previous data also.
Yes, sir.
So as such, we can say actually in ETCS we have got JRU similar to IDL.
Okay, sir.
So actually that also is the requirement is like SIL2 for JRU. Here also, even if power is gone, because it will remain stored for 3 months in that locomotive's data logger unit, internal data logger unit.
Thank you, sir. Sir, what?
Munikumar, if
Sir.
you wish, I have shared on WhatsApp. I have sent one diagram to just explain the people like how the brake thing is fail safe. If time permits, you can show that. Otherwise, you can just see on. I have sent on your WhatsApp.
Yes, sir. Yes, sir. Sir, just I will share that one. Sir, first we'll complete this one presentation. Sir, can you see the second next point, sir? What is the effects of the thunders and lightnings on the onboard equipment? How earth value will be maintained? Sir, I request Manskar sir to kindly answer this question, sir.
Okay. Katya Kumar, है ना?
Yes,
I'll
sir.
tell you, actually, this system has been type tested as per Senelec norms for ability to withstand to EMI, EMC, electromagnetic interference, and those requirements for testing. This is quite stringent actually. Actually, you must have seen that our electronic interlockings also undergo fault conditions during lightning, etc. Now, of course, the frequency has reduced greatly, but the environment is very harsh in locomotives. So unless until we test that, it will not be possible to have some simple design on the locomotive. So it has been already type tested. I will tell you. I will just give you glimpse. Yes, there is provision. For example, there is one test in which one antenna with interfering signals of the order, which is as high as 10 volt per meter, that will be made to direct. It will be directed towards the equipment under testing. And that equipment will be kept on one thermocol platform, which will be rotated for 360 degree. After 360 degree rotation, and equipment should remain functional. After 360 degree rotation, then height of the antenna is changed by 50 centimeter, like that. After one antenna, another interfering signal, another antenna is kept. For example, first log periodic is kept. All these procedures have been defined in Senelec norms for all those things. So even after that, if something is coming, that we have to look into it. But since that hardware has been tested for that, these type of situations we have not come across thunders and lighting in onboard equipment. So what we have to do for that, we have to design the system accordingly. For example, shielding. I remember initially shielding was not proper in Kernex equipment at the design stage itself. So it was likely that test would fail. Then shielding was done properly. That earthing, inside earthing also. So that is taken care. What I'm trying to say.
No, but Mansukani, I have got one doubt in my mind.
Yes,
See,
sir.
what are the tests and other things you are basically mentioning is at
Yes, sir.
time of testing stage, when these subsystems are integrated in the locomotive environment,
Yes, sir.
and after system integration, any such test has been carried out.
Sir, I'll tell you, sir. Actually, there are two types. One is ATF and one is type test format. Elaborate tests are there in type test format, but in acceptance format, like during regular manufacturing, these type of tests are not there, sir.
That okay, a subsystem, because the entire loco equipment what has been fitted, it is basically system integration,
Yes, sir.
and there are subsystems. Okay, subsystems have been tested for this lightning and surge protection or whatever you call it. So all EMI the compatibility has been established, but when it is integrated with the other equipments, then what is the effect? Are we have we done any such test over the after system integration?
Sir, actually, that's what I'm mentioning. Initially, during type testing, with full-fledged integration environment, which are specified in Senelec norms, sir. According to that, for example, there is another test, 7 kilovolt discharge test. that could be done only after integration. So that has been done, but sir, those have been done only at you can say a type test stage, that is design. We can say design and development stage. But during like we are accepting some particular lot of particular lot, then that lot for that lot these tests are not there, sir.
Okay.
Only through visual inspections and other checklists like wiring is proper, this that we need to see, and internally OEM should show their reports of while supplying the material. OEM should show the reports of their internal QA team, which tests have been carried out by their internal QA team. We should insist for that. I had told the South Central Railway people also, sir, earlier also, we should insist for those, because OEMs do carry out these tests. Some, not all type tests, whatever are because that facility is not available everywhere, but whatever test they are doing, apart from RDSO test report, we should insist for their internal test reports also.
Okay. Go to next question, Manikumar.
Yes, sir. Sir, from the STDC Maulali, will RFID tag data from the ground to loco fail if any copper, foil or other metals falls on bellies? Yes. Srinivas, whenever any metal fully covers this RFID tag, the data transfer will be affected and it will start malfunctioning with the metals. We'll go to the next question from the Narayan Raju, SSC Tele, Samalakota. Good afternoon, sir. Loco KAVACH
What are the mitigation measures available for such eventualities?
Sir, I'll tell you, sir. Suppose in case of a bridge, metallic bridges and all, what we'll do, we'll try to switch off the BTMs in case of TBWS. Here also, we are supposed to do it, but these days there is no bridges. But for a small thing, we are having duplicate tags. So one tag is generally affected with such type of a copper foil, all those things. The other tag will be available. Even if both tags are failed also, it is not a actual failure for the system's sake. So it will always take the next, unless 4 tags are really damaged with this type of file, all those things only will be affected with the operations. Apart from that, sir, such tags will be identified in on the locomotive itself, sir, on the DMI. Otherwise, there is no much preventive measures only, sir. There is no much system preventive measures is not there, sir. These are all considered as
yeah, I think it should satisfy the query raised by, I think, Srinivas or from the STTC Maulali.
Yes, sir. Thank you, sir.
That is single interference on the RF ID tag, RFID tag will not affect the performance of the system, negate the performance of the system.
Right, sir. Thank you, sir.
Go to next question.
And just to add, sir, Srinivas, actually, whenever one of the tag is missing, let us say everywhere we are providing 2 tags.
Okay.
So one of the tag is, let us say, missing. So although operations will not get affected,
Okay,
the
sir.
information of missing will immediately go to NMS through our SIM card.
Okay.
That one of the tag is missing. So through that it will be routed to maintainer. So operations will not be getting affected, but maintenance team will come to know that we should go and restore before another tag also goes off.
Sir, any SMS?
Srinivas, your voice broke in between.
Sir, any SMS given to the
Yes. SMS there. I will directly send you one screenshot of SMS to you just now.
Okay, sir. Right.
Okay.
Thank you, sir.
Sir, Mansuhan, sir, kindly see the next question, sir.
What is the next question?
Sir, I will read, sir. Sir.
Loco KAVACH is exclusively dependent on wireless communication. Is it prone to signal jammers as it lead to communication failure? Number 1. Please explain how track side RF tags are authenticated to make them tamper proof. Okay. First of all, yes. If there is some jamming, system will not function. Signal jammers can jam the communication. No protection against that as of now. And system will go to, of course, fail-safe mode, but there is no protection against jamming. I hope, Narayana, this satisfies you first query. Now,
Yes, sir. Is there any possibility of shifting to different frequencies whenever jamming happens in one particular frequency? Is there
I'll
any?
tell you. Actually, there are techniques of like spread spectrum, etc., in which we
Yes.
keep on hopping the same information in different frequency ranges. But what will happen whenever jammers do this? They go for wide range of frequencies.
Yes, sir. Wide band.
And moreover, whenever we are going for such type of technology, then our requirement of spectrum also will increase.
Yes, sir.
Number three, normally, if you see, jammers will do it for what purpose? Whenever, let us say, there is some VIP, very, VVIP visit is there, then only jammers are provided, otherwise, normally, for terrorist activities, etc., if they try to do, there are other means to cause sabotage, not through communication jamming, but as such, there is no provision for routing the information through different means or different frequencies.
As there are so many GSM jammers are available in market actually, it is very quite cheap actually. They can put a system into not a good state actually.
Yes, and it is easy to track jammers also nowadays. But of course, whenever jammers are used, system will not function. Means it will go to safe side, degraded mode. It will come out of full supervision mode. It will tell the driver, our user, that I am not able to provide protection. You take over. It will be safe side failure.
Yes. But it is a
Now,
harassment to local pilot.
yes, it is harassment. It is harassment. So we have to see how frequently it can happen. So accordingly, we should decide whether to provide multiple frequencies and broader spectrum or not. So we feel that there is no need to provide broader spectrum just to tackle this problem. Now, next query is how trackside RF tags are authenticated to make them tamper
It's a
proof.
tamper proof, sir. It is a typo.
Okay, tamper proof. Yeah, I'll tell you. Actually, there are two modes of programming these RFID tags. In one particular mode, when you program it, then you can reprogram it again and again, like as we do with E square program, hai na?
Yes, sir.
Then finally, once you are satisfied that data is as per uh, uh, final requirement, okay, then what you can do, then you can simply program it in another mode, that is, you can say data will be logged. Once you program with that particular mode, then it will not be possible to reprogram that tag again and again. So these are the two different modes of programming RFID tags. So when you are sure that after doing site acceptance tests, etc., that now there is no more further need to reprogram that same tag, then you can finally permanently burn it. Then it will not be possible to reprogram. So actually, incidentally, this same query was asked during one high-level meeting. Honorable MR and CRB were there, and at that time I told them about this particular aspect. So it was decided that whenever you are finally, your layout is final, data is final, then you have to burn it in a manner permanent. You have to so that that particular mode. It is given in manual also.
Sir, another thing, sir, Kavach is also used for speed restrictions in tight curves and bridges all. And is it possible to read the data and copy it to another RF tag and you can place it somewhere and you can restrict the speed of the train?
Yes. Actually, first of all, every tag has got its location. Suppose one unidentified one tag is located at some other particular location. So
Yes, sir,
because
got
the
it, sir.
sequence
Sequence is
will
also
get
included.
disturbed. Hello. Yeah, please.
Location data is also tagged, mapped with the tag data, sir.
So basically, this is also one of the safety requirement. Then whenever we are programming the tags, we have to follow the checklist. And during PV work, etc., also the location of tags should not get disturbed. Number one. Number two, in one of the cases we have found on South Central Railway incident also, like initially there was some software version of RFID reader which was initially 8 or 9 years back, in which it was not reporting the reading of the text to the vital computer in the order in which they were actually read. So it was out of order reporting. So 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 later on we got this software modified by OEM of RFID reader. So incidentally, that particular software was not replaced in that particular onboard unit. So first of all, we have to ensure that our softwares are updated as per RDSO approved versions. Number one. Number two, like suppose, yeah, one more check what we are doing now. In version 4, we will be sending the list of RFID tags with their location in advance on radio to the onboard unit. What I'm trying to say is that train is expected to follow a particular route. So whatever RFID tags will be encountered by the train, as expected, will be given to onboard unit or locomotive in advance with their locations. Okay, so now whenever train is moving, it will read those tags, and if there is any mismatch, it will report that as something has happened, something wrongly located thing has happened or not. I will tell you, in Agra Delhi section in TPWS or ETCS level 1 installation, when third line work was being carried out, during my inspection I had carried out one such interchange of balises. Because of that, unsafe situation was being created. So we have to be very careful about installation. Of course, now, as I told in version 4, we'll be getting list with locomotive in advance. It knows that what all tag numbers I will read.
Thanks, sir. Thank you so much. Thank you, sir. I will go to next question, sir, from the Raghavendra. Sir, few months back, heard about signal jamming near Sanat Nagar while some military special. Moment during which our mobile communication around Sanat Nagar not functioned. Need to check the effect on our cover system. As our Manskan sir, I already explained in the previous, the answer is same for the jamming. So whenever jamming happened, our communication RF will be interrupted. System will be transited to the degraded mode, and it will alert the user.
Noted, sir.
Sir, with this, sir, all the queries in the chat box have been completed. And any other questions?
Monikumar, I have quickly run one this thing.
If there are
yes,
no
sir.
more
Yes, sir.
questions,
Yes, sir. Yes, sir.
If time
If there
permits,
are-
then we can explain.
Yes,
so
yes,
if
sir.
there are no questions, let us close it.
Yes, sir. Thank you, sir. Just once again, sir, I requested one thing, sir. Sir, this screen is visible, sir.
Yes, sir.
Sir, once again, sir, this is visible, sir.
This is visible, but whether if with PCSC sir's permission, it will take 2 minutes. Shall I explain this or shall we conclude?
Yeah, explain it.
Sir. Sir, I'll tell you actually, if you see this particular diagram, this is like this is to address Srinivas query, STTC Srinivas query. Srinivas, you can follow like as we provide in our signaling circuits also. Relays normally we provide in pickup condition. Here you see that MR is there, and BP line, and you see at the bottom BP line and exhaust. So what we have to ensure that path from A and B at the bottom you see, it should not be made through. Once it is made through, then all the BP pressure will get exhausted. Okay, that is the thing which we have to do. Now, in order to prevent exhaust of A to B, what we have to do, there is one pneumatic control, valve D15. This I have taken from, actually all OEMs have got this, I have taken from piping diagram of MEDA, old version maybe, or IRAB version. And then again you see that pneumatic control, that control signal itself comes through MR. Means A2, A3, there should be, it should be in pickup condition. Then only MR will be available. And this signal comes to D4 from electrical signal from vital computer. Like if there is any problem in vital computer, then then there will be then also this BP line will get exhausted. So apart from heartbeat monitoring of brake system, this also will keep on happening. So basically, BIU in itself is not fail safe, but the way we have provided in our system is fail safe. Actually, loco equipment are not termed in terms of SIL4 and all brake system, etc. They are deriving the brake fail safety in indirect method. I'll just quickly once again repeat, like electrical signal from vital computer would be available at the control port of D14, which would cause D14 to allow air to flow through A2 to A3. A2 is input side and A3 is output side. Okay, and MR is at A2. Okay, this in turn would extend MR pressure from A2 to A3. I hope this is clear. And this will be going to the controlling port of D15, which would in turn, what it would do, it would ensure that the path between A and B remains blocked. Okay, so port A is connected to BP and port B is open to exhaust, and path between the two is blocked. That is what. I hope it might
Okay,
have
sir, understood, sir.
satisfied us to some extent. All other circuits also similar to this. Thank you. On the basis of my memory, I have drawn maybe D14, D15 के बजाय हो सकता है it may be D15, D16 or whatever.
Thank you very much, sir. I sincerely thank our PCH sir for giving this opportunity for delivering this lecture on the Kavach fitment. And I also thank our V number officer CST projects and BK Agarwal sir and Manskani sir for supporting and guiding us. And I also thank all our colleague officers and all the participants for actively participating and contributing their valuable inputs in enlightening our thoughts. Thank you. I request our PCH sir to do the concluding remarks for closure of the session.
I think we have discussed quite a lot, and a lot of new learnings has also come out. And there are some very good questions on which we have to further work to further refine and improve the system and make it much more user friendly, maintenance friendly, and of course fit for the purpose. So let us take it forward, and I hope that some more studies and some more further deep dive into the topic is required, so that the people who are involved in the installation, testing, and certification. In fact, I would like you to just dedicate one more paper on the testing. Once the installation is over, then let us try to educate our people, because a lot of people will be involved in signing the pre-commissioning checklist, verifying the installation, do the acceptance test procedure. So let us work on this, and phase part 2 of your presentation should cover these testing and acceptance of and certification of the locos, including this SAT. So let us work on this and enlighten our people in the field. Thank you.
Thank you, sir. Thank you very much, sir.
Manjunath, you may close.
Yeah. Thank you very much, sir. FTCS team, Sri Muni Kumar sir, and all your team, sir. And it was a very brainstorming session. I thank CST project, CSC sir, and giving his perspective on this project, and also COE Sri Mansugani sir. And finally, I thank PCST sir for being a continuous guidance and motivation to all of us in this session. And thank you all the participants who has been given valuable questions and interacted with the presenter. Thank you very much for one and all. Sir, we conclude, sir.
Yeah. Thank you, Manjunath.
Thank you. Thank you.